Now we continue on and we're looking at cube root of 3 times cube root of 8. So again, really quick, something I didn't mention. If you look at the nth root of x over the nth root of y, that is x to the 1 over n over y to the 1 over n. That is really x over y to the 1 over n, or simply the nth root of x over y. So we could skip all of this mess and jump straight. And with the same token, I could say the nth root of x times the nth root of y. That is x to the 1 over n times y to the 1 over n. Isn't that the same thing as saying I must have had xy both raised to the 1 over n? And I could eliminate the middle step and go forward and backwards. That's very important. So when I glance at this, I automatically figure out that, you know what, instead of going through all of that process, why don't I just combine those into one? You could, of course, you have a couple of options of doing this. You could say that's the cube root of 3 times the cube root of, and that's 9 times 2. That would be the cube root of 3 times 9, that's 27 times 2. What do you multiply by itself? 3 times to get 27, a 3, and what's left underneath the radical? A 2. And that would be my final answer. And similarly, as long as those are the same, it's fairly simple. You could combine into a single radical, and if you multiply those, 1 times 24 is 24, 3 times 1 is 3, and that is the fourth root of 24 divided by 3 is 8, and that's pretty much it, because for a quantity to declare the radical, the fourth root, it must be multiplied by itself 4 times. The best I can get out of 8 is 2 times 2 times 2, 3 times. And if I glance at this, well, a couple of options as well. I could write this as a single base. Since the denominators are the same, I could simply add the top. 2 plus 5 is 7 over 3. And that would be the cube root of x to the 7. And I could clear that even a bit more. That is, how many 3's are there in a 7? There are 2 of those. And what's the left over? Of course, you don't have to write 1. I'm just writing that down for your notes. And here, I could say, well, that's y. This is not matching. I'll do that in 2 steps. Well, what do you know about fractions? We get a common denominator. So making that an 8, you multiply the top and bottom by 2. That's a 6 plus 5. So that is y to the 11 over 8. That is 8th root of y to the 11. So how many 8's are there in 11? 1. And what's the remainder? How many are left? If you divide 11 by 8, that's 1, and you have 3 left overs. And if I glance at this problem, I have a couple of options. I could distribute that in. That's 2 to the 3 halves. That is x. If you multiply 4 times 3 halves, 2's cancel out. You're left with a 2. 2 times 3 is a 6. And the denominator y, 6 times 3/2. 2 divides 6 3 times, that's a 9. So the only value that I have to worry about is a square root of 2 cubed, which is an 8, x to the 6 over y to the 9. And 8, there's the radical as it's 2, because that's 4 times 2, and you have 2 left over. And there it is. Alright. Next problem up. Couple of ways I could do this. I could say that is x to the 12, y 1/3 of 6 is a 2, z 1/2 of 6 is a 3. Here I have a couple of options. I could take the reciprocal. I could distribute straight in. It really doesn't matter. I could say, you know what, this is x to the 8. Oh, those are x's. They're both x's. Okay. I could switch them. I could combine before I begin. That's saving a lot of work. That's actually x to the 10. And like I was doing, there are a couple of options you could do this. And both, or as many, will work. You could distribute that straight in. Or you could say, you know what, let's take the reciprocal. And that would be x, half of 10 is a 5, and y, half of 4 is a 2. That is, when you multiply, you add powers. Z cubed is 1 of a kind. And when you divide, you subtract powers. And that would be, oh, they're matching, they're just cancel out. That's like y to the 0, and we know y to the 0 is 1. And that's pretty much my answer. And k, the same deal. Couple of options I have. I could distribute that in, say, okay, well, let's see. That's 16. 16 is really saying 4th root of 16. What number do you multiply by itself to get 16? That's a 2. Or you could say that's 2 to the 4th. And when you erase powers, you multiply, you end up with a 2 to the 1. 1/4 of 4 is 1. 1/4 of 3/4, the 4th cancel out, that's a 3. And 1/4 of 8 is a 2. And here, 3 divides 6 2 times 4, that's 8. And 3 divides 9 3 times, and the 4's cancel out. And the denominator, the 3's cancel out, and 4 times 1 is 4. And now if I combine x to the 9, y to the 6, and y squared times z squared times z to the 4th is z to the 6, because you add powers, if you remember. Oh, if I want to write that as an exponential, that's y to the 5 over 3. Or if it says simplified, that's not asking for you to write it as an exponential. Instead, what you're really supposed to say is, well, this is y cubed times y squared. Those 3 clears the cube root as a y, and you're left with a y squared underneath the radical. Oh, too close. A y squared underneath the radical. And here, well, a couple of ways you could do this. You could say x to the fourth times x squared. This clears the radical as x, this clears the radical as x, so there are two of those. And how many are underneath the radical? Two left over. You could also say 4 divides 10 two times, that's 8, and you have two leftovers. However you do this, this is going to come back and forth. It's not like really you're going to see it all the time, but it's going to go away and come back. Let's practice here. How many 4s are there in 7? That's 1. The leftovers always remain under the radical. If I took 4 out of the 7, then I have 3 left. If I multiply those, well, the index and the radical doesn't match. I could say that's x y squared to the 1/3 and x to the 4th y to the 20th to the 1/6. Distributing x to the 1/3 y to the 2/3, distributing 1/6, that divides by 2, that's 2/3. And 1 divided by 6, 20/6 is 10/3. And when I get to the x's, those have the same denominator. I write an x. 1/3 plus 2/3 is 3/3, which is 1. And 2/3 plus 10/3 is 12/3. 12/3 is a 4. And here the indexes don't match, and nothing simplifies, but I could say that's x to the 1/3 and y to the 2/5. And from what I know, if the denominators don't match, I'm going to get a common denominator, which is, which is what in this case? Okay, I see I'm messing up. And if you add those, 1/3 plus 2/5 all over 15. Six plus 5 is 11. So this is saying this is the 15th root of x to the 11. And if I'm adding, addition is a lot more tricky than multiplication. To add, you must have the same terms, or you must be able to reverse the distributive property. Well, this is really 9 times 2. I'm looking for perfect squares, and this is 4 times 2. So the 9 clears the radical as a 3. You have a 2 left over. And the 4 clears the radical as a 2, and you have 2 left over. And if I factor out the reverse the distributive property, if these are real numbers, then you could add 3 plus 2 is a 5, radical 2. Of course, you don't need to show that, but for starters, it's a good idea if this is a bit confusing to you. Same deal here. I say, well, okay, that's 25 times 3. So 25 clears the radical as a 5, and you have radical 3 left. And square of 25 is 5. Basically, you're done. You could, of course, factor a 5 out if you want. You don't have to. And that would be really the answer. But it's the same thing. Both of us are saying the same thing. And here we say, well, okay, these are multiplied, so 3 is a perfect squared. 9 is a perfect, sorry, you know what I mean. And 2 divides 5 2 times, and we have 1 left over. And since this is a variable, this is a number, this is pretty much as far as we go. Now be really careful with the plus. Because of this plus, I can't touch this or this. What I could do, I could factor, which is coming up in the next section. I could factor a 4 out and an x. Out of this, I'll have 4x left, and out of this, I'll have a 9. Now, the fact that this is multiplied by this, well, this is not a perfect square, this is not, but the 4 is. I could take that out. I'll have x into 4x plus 9. Okay, almost there. I just want to make sure that I touch on all the topics that we need. Simplify. You can't leave a radical in the denominator. So, idea is thinking out loud. If I could have had a square root of 4 in the denominator, that would be perfect. And the way to get there, well, it's fairly simple. In math, we are allowed to add a 0 anytime we want, and we could multiply by 1. So pretty much, to get a 2 in the denominator, I must have a radical 4, since we're dealing with radicals. And the only way to get a radical 4, if I was to multiply the denominator by a radical 2, because square root of 2 times square root of 2, you write a single radical, and 2 times 2 is 4. But in math, all throughout, we have only two basic rules. You could add a 0, or you could multiply by, since I'm multiplying, you could multiply by 1. To make that a 1, you make sure the quantity at the top and the denominator are the same. And if I multiply 1 times radical 2 is radical 2, and there it is. 1 over radical 2 is the equivalent of radical 2 over 2. Of course, I'm going to take this out. It's not part of the problem. But that's how we do this. If I look at part V, well, I notice here we have a cube root. Now I'm thinking, if I could only have the cube root of 2 times 2 times 2, so wait a minute, well, that would clear the radical, obviously, but that would mean you must have multiplied the denominator by cube root of 4, because 2 times 2 is 4, and the rule is you're allowed to multiply by a 1. How do you make this ratio a 1? Whatever the denominator is, you make the numerator the same. And that's a ratio of 1. 1 times the cube root of 4 is cube root of 4. And what would that be? That is cube root of 4. Those clear the radical as it. Alright, next problem up. Well, obviously I know what to do. If I think backwards and I say, what do I need to get a 2 in the denominator? I need 4 of those, because that's a 4th root. Well, I have 1. I'm missing 3 more. 2 times 2 times 2 is 8. Since I'm only allowed to multiply by a 1, I make that a 1 by forcing the top and the bottom to be the same. 1 times 4th root of 8 is 4th root of 8. Well, this is x divided by the 4th root of 2. Same deal. To get a 2 in the denominator, what must happen? I must multiply the denominator by, I need 4 of those. I have 1, so I need 3 more. But I know 2 times 2 times 2 is an 8. So the denominator will be simply 2, and the top will be x times the 4th root of 8. And that problem right there, well, to clear the denominator, again, I can't have a radical in the denominator. That wouldn't be simplified. Well, let's see. I look, well, there's a 2. I need 4 more. 2 to the 4th is 16. And remember, I'm allowed to multiply by a ratio of 1. I have 2 x's. To make them a 5, I'm missing 3 more. 4 y's. To make them a 5, I need 1 more. And 3 z's. To make them a 5, I need 2 more. Now the top, 1 times any quantity is that quantity. And if I did this correctly, I should be seeing a simple 2xyz in the denominator. And that's pretty much it for this section.